Okay, now we're looking at long division using a 4-digit dividend. Over here on the right, I have 9 times 1, which is 9, 9 times 10, which is 90, 9 times 100, which is 900. And I am using my long division Fantastic 7 packet. Okay, if I come down here, I can do 9 times 1,000, which we know is 9,000. So as a reminder, division is just repeated subtraction. But I do not want to do minus 9, minus 9, minus 9, minus 9 over 100 times, because I'm probably going to make an error if I do that. Does that make sense to everyone? Okay. So I cannot subtract 9,000 though. I'm going to continue subtracting from my dividend until I get a number less than 9. Can I subtract 900?
Yes.
Yes. Okay. Now we did talk for just a minute, and I'll show a picture for people who were not in here, that if I just started subtracting 100, then I would get 5,425. I'd have to subtract 900 again. Okay, again, then, I could go 900 again, I can go 900 again, and I would have to subtract 900 7 times. And that, again, is leaving 7 opportunities to make a mistake. So we want to subtract as little or as few times as possible. Okay, so what we can do here is we know we can subtract 900, and we know we cannot subtract 9,000. So if we go halfway between that, 9 times 500 is what? What is 9 times 500? Stella?
4,500.
Very good. 9 times 5 is 45, and then I need to add my 2 zeros. Can I subtract 4,500? Yes. Okay. Well, I wonder if I could do subtract 600 times. What is 9 times 600? Ella?
5,400.
Very good. 9 times 6 is 54, and then I'm adding 2 zeros. Can I subtract 5,400? Yes. Let's try 7. What is 9 times 700? What's 9 times 700? Morgan?
6,300.
Very good. 9 times 7 is 63, and we can add our 2 zeros for 6,300. Can I subtract that? And that's really just going to leave me with 25. So this is a little more work on the front end, but it's a lot easier than subtracting 107 times, right? It's a lot easier than that. So let's go ahead and subtract 9 700 times. What we are literally doing is we're saying I can subtract 9 700 times. And instead of doing minus 9, minus 9, minus 9, minus 9, minus 9, 700 times, I'm chunking that together to subtract 6,300. And that just leaves me with 25. Can I subtract 900?
No.
Can I subtract 90?
No.
Can I subtract 9?
Yes.
Okay, but can I subtract bigger than 9? What is 9 times 2?
18.
Okay, what is 9 times 3?
27.
So that's too big. Okay, so 9 times 2 is 18. So I'm going to subtract 9 2 more times. Don't forget to put, these are called, what are these called over here on the right? Partial quotients. Don't forget to put those on the right. And now I have 7 left. Can I subtract 9 again?
Yeah, no.
No. Okay. So I need to add together my partial quotients. So my quotient is 702. And what is my remainder? 7. 702, remainder 7. So who can tell me, how do I multiply back or use inverse operations to check my work? MJ. 702 times 9. Use the strategy of your choice. Okay, I do want to show you this on 702. You can just break it apart like that. You don't have to put 700 plus 0 plus 2 times 9. And then over here, we already did 9 times 700. And up here, we already did 9 times 2. So really, the partial products are already there for you, right? So 9 times 7 is 6,300. We already had that over here. 9 times 2 is 18. Add together our partial products. And we have 6,318. What do I need to do to check against my dividend? Before I check, I have to do what? Addie?
Add the remainder.
Add 7. Very good. Is that the same?
Yes.
Okay, so I am correct. We did it correctly. Do you guys want to do one more 4-digit?
Yes.
Let's do it. Okay, so, okay, over here on the right, I'm going to go ahead and add 7 times 1,000 because I have a 4-digit dividend. Okay, so what is 7 times 1,000? Owen? 7,000. What is 7 times 100? Ireland. 700. 7 times 10, Morgan. And 7 times 1, Harper Cook. 7. So can I take my dividend? Remember, I'm going to continue subtracting from my dividend until I get to a difference that is less than 7. Can I subtract 7,000? No. Can I subtract 700?
Yes.
But that's not very, please stop disrupting. That's not very close to 3,641. So let's do like we did before and go halfway between 100 and 1,000 and do 7 times 500. What is 7 times 500? Ryan.
3,500.
Very good. 7 times 5 is 35. Add your 2 zeros. Can I subtract 3,500?
Yes.
And that's pretty close. So let's try that. So remember over here on the right, we want to put our partial quotient, which is 500. We're saying I'm going to subtract 7 500 times. But I'm going to make it easy on myself and chunk that all together into 3,500. That leaves me with 141. Okay, so can I subtract 70? Yes. Let's try, that's not that close, so let's try 7 times 20. What is 7 times 20? MJ? Good. 7 times 2 is 14. Add a 0. That's pretty close, isn't it?
Yes.
So don't forget that partial quotient, which is 20. Notice over here I'm lining up my numbers to make it easy to add. And then I'm subtracting 140. I'm subtracting 7 20 more times. And that leaves me with 1. Can I subtract 7?
No.
No. So I add together these partial quotients. So my quotient is 520 and I have a remainder of 1. Okay, how do I multiply back to check? What do I multiply to check my work? Avery, what should I multiply? Okay, look over at the one on the top. What did we multiply here?
Multiply
520 times 7. Use any strategy that you want to do 520 times 7.
To get that 140, you write 7 plus 20. That 20 needs to be underneath this, it's your partial product. Oh, I didn't see it, okay, but you didn't write the 20 over here though. Forget that, answer buddy.
Okay, what did you get, Eli, when you did 520 times 7?
3,600.
Well, not when you did 520 times 7.
3,600.
3,640. So again, if we break it apart like this, okay, I already had 7 times 500 over here. And I also already had 7 times 20 over here. Okay, so when we add that together, we get 3,640. And then what did I need to do, Eli? Add my remainder, which is 1. So now I have 3,641. Does that match my dividend? Yes. Okay, show me on your fist. 0 means I have no idea what I'm doing. 5 means I am awesome at this and I can show someone who doesn't know how to do it. Okay, so, and 2, 3, 4 are somewhere in between. Show me how you're feeling. Okay. Okay, that's pretty accurate probably. Okay.